Hello. In this module we will learn about the logic behind refrigerants names, their environmental impact and concerns, and the quest for finding or inventing the most suitable refrigerant. Refrigerants are named using a prefix that is usually the letter R, and suffix which is a combination of numbers and letters. The prefix usually starts with the letter R, while other letters such as C for carbon, a combination of B, C, and F for bromine, chlorine, and fluorine, and H for hydrogen are used. For example, it is also common to use CFC, HCFC, or HFC instead of R for the prefix. The suffix contains 4 numbers that indicate the number of fluorine and hydrogen atoms, the number of carbon atoms -1, and the number of double bonds in the molecule. Notice that if any of these numbers are 0, we simply don't write them, or mention them. Lowercase letters are used to indicate isomers, while uppercase letters such as A, B, or C indicate different percentages of refrigerants blended together. Now let's practice. On your screen, you see a refrigerants molecule. Step 1. You can count the number of fluorine atoms. How many Fs do you see? The answer is 2, and that is our first number from right. Step 2. How many hydrogen atoms can you count? The answer is 1, add 1 to it, so the second number will be 2. Step 3. How many carbon atoms do you see? The answer is 1, deduct 1 from it, so the third number will be 0, therefore, we don't write it. Step 4. This molecule does not have any double bonds that look like the equals symbol. Therefore our fourth number will be also 0, so we don't write it. So we can confidently say that we are looking at the R22 refrigerant molecule. Let's look at another example. On your screen, you see a refrigerants molecule. Step 1. You can count the number of fluorine atoms. How many Fs do you see? The answer is 4, and that is our first number from right. Step 2. How many hydrogen atoms can you count? The answer is 2, add 1 to it, so the second number will be 3. Step 3. How many carbon atoms do you see? The answer is 2, deduct 1 from it, so the third number will be 1. Step 4. This molecule does not have any double bonds that look like the equals symbol. Therefore our fourth number will be also 0, so we don't write it. So we can confidently say that we are looking at the R134 refrigerant molecule. Refrigerants are grouped into different series based on their composition. You do not need to memorize them, but knowing them and their standards is good knowledge to have. Refrigerants have environmental impacts, including ozone layer depletion and global warming. The ozone depletion potential, ODP, of a refrigerant measures the relative amount of degradation to the ozone layer it can cause, with trichlorofluoromethane, R11 or CFC11, being fixed at an ODP of 1.0. Note that the chlorine in the refrigerants molecule reacts with the ozone. As a result, the ultraviolet protective layer of the atmosphere weakens or gets destroyed. Thus, the rate of skin cancers, eye cataracts, genetic and immune system damage increases. The Montreal Protocol legislated to stop production and use of ozone-depleting chemicals. The global warming potential, GWP, of a refrigerant measures how much heat a greenhouse gas traps in the atmosphere, relative to carbon dioxide. Unfortunately, some of the refrigerant commonly used nowadays have a high GWP. You can find tables such as this one that show the ODP and GWP of each refrigerant. Not all elements are suitable to make a refrigerant compound due to various reasons such as solidification at certain temperatures, high toxicity, or rarity. Some replacement refrigerants that are suitable include carbon, C, nitrogen, N, oxygen, O, sulfur, S, hydrogen, H, fluorine, F, chlorine, Cl, and bromine, bridge. However, some replacements, such as ammonia, NH3, are flammable and toxic, while sulfur dioxide, SO2, is toxic. Chlorofluorocarbons, CFCs, are phased out for their high ODP and GWP, while hydrochlorofluorocarbons, HCFCs, are being phased out as well. In addition to phasing out ozone-depleting refrigerants, it is also important to consider the impact of hydrofluorocarbons, HFCs, which are commonly used as alternatives. While HFCs do not deplete the ozone layer, they have a high global warming potential and contribute to climate change. Therefore, efforts are being made to find more environmentally friendly refrigerants that have low global warming potential, such as hydrofluoroolefins, HFOs, hydrocarbons, HCs, and natural refrigerants such as carbon dioxide, CO2, and ammonia, NH3. Moreover, another trend in refrigerant technology is to find a suitable blend or chemical composition of refrigerants that can provide optimal performance while minimizing their environmental impact. This involves considering factors such as energy efficiency and safety, among others. By reducing the use of harmful refrigerants and adopting more sustainable alternatives, we can help mitigate the impact of refrigerants on the environment and move towards a more sustainable future.